Alright, welcome back to the Chem 324 programming tutorials. We're going to go through Module 4, which is about input and output, otherwise abbreviated as I/O. So what we want to do with I/O is to be able to take in input or return output in some way, shape, or form. So we've already been doing a lot of outputting. Println and writing to the console is a type of output. We can actually read from the input as well, read from the command line. It doesn't work in Jupyter, so you have to go to an actual Julia file. So if you're not running on a regular computer, you can't do this, but just for your own edification, you probably won't ever really need to do much of this, and ignore my computer doing a random thing the first time I run it. So you can type in your name, and it will print out what is going on there. So I'm giving the user a prompt. We're doing a read line, so the function to read what the input is read line. So it takes all the text that you write in the console, and then the person presses enter. It will then put that into that variable A, and then we're printing hello A. If you ever played a console app game like Oregon Trail or whatever when you were a kid, this is what this was. They were console apps. One thing you might have also seen back in the day was like press any key to end program or something like that. That's what this is doing. It's the same kind of thing. So we're just throwing it away and not using it. But Jackson, you have to hit enter, but you know what I mean. So that's a console app. Probably won't ever need to do it, but that's the kind of the easiest type of input. The next type, and the more useful really type of input, is file I/O. So there are a few different types of files that you might use. So plain text, plain txt, plain text, which are saved in .text files. So it's just, ABCD 1, 2, 3 in a text file. You can read and write to that. Comma separated values. So these are just really text files that are in a specific format, and we'll see that. And then JavaScript object notation, which is a way of taking objects. So like those bikes and simulation stuff we did in the last module, you can save the complicated structure of that and then use it later on. We'll show examples of all that. So Julia provides us a function called open that allows us to open what's called an I/O stream. An I/O stream gives us access to a file. We can use these character codes in the function to specify what we're going to do with it. We're either going to be usually using read if we're only going to read, or write plus, where write takes and deletes everything that's in the file, or creates the file if it doesn't exist, and then puts your text in there. Append does the same thing, or append plus, but instead of getting rid of everything, it appends new text to the end. So we'll see how all that works here in a second. Anyway, so let's open one up, and we're going to write to it. So we're using our open method. We're using kind of write plus, which will create the file if it doesn't exist. And we will see at the moment. Let's delete it so it doesn't exist. I have some stuff from previous runs. Let me delete those before we start. So I'll go ahead and run this. And there we go. So it created the file for us, hello output.txt, and there's our text that we passed in. We passed in a string. We can do it again with some different text, run it, and what do you know? It blew everything away and put in new text. Now we can use A to append. We know the file exists, so we don't need to use A plus at this point. And we're also using this \n, which will create what's called a carriage return, so it'll go to the new line for the next bit of text. So we've got a second line of text. That's what we did before with this \n. So it went on to, let's pull this over to the side so we can see it while we're doing it. Then we can do a third line of text. Notice that we wrote without a \n, so no matter how many times we do this, it will stay on this same line. So that's what the \n does and what append versus write does. All right, now we can read from a text file. So we are going to read from hello input, and hello input file input only has one line. We're going to read that line. So the function that we can use to get a line of text is we have an IO that's in read mode or some mode that allows us to read, and then we run that and it pulled it out of here, and now we printed it out. So that's how you can get text. There are multiple ways that you can do multiple lines of text. So I'm going to open up a multi-line text file over here, and there's kind of two main ways. You can either use the read lines function, which is more likely what you're going to use. That'll give you all the lines. Basically just boils down to the size of the file, or if you know you don't need to use the whole file, if you're searching through text or whatever. So I can give you a moment to read through that. So I'll assume you've read through that. We will do this loop method. So we have this end of file function that basically, and I'll run through this loop kind of without actually running the code of how it actually is going to work. So we're opening the file, so the IO object will be kind of where my cursor is right there before line 1. It's going to check, am I at the end of the file, which it's going to find that it's not. So we'll go into the loop. It will do a read line, which will give us that text and then put us at this pointer. We'll print our text, so it'll print line 1, loop, 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 1, 2, line 3, line 4, going through the motions, and then it checks if each time if we're on line, if we've got the text line 4, and if it is, it will break out of the loop and not print line 5. So we've found our first 4 lines, which is what we were trying to find. You could do a lot more complicated things, but this is the basics of how you would parse through a file and try to find the thing that you wanted. Here's the same thing with read lines. So this just grabs all of them, loops over all of the lines and prints them. Fairly self-explanatory. All right. So now we'll talk about comma-separated lists. So these text files are, like I said, they're just basic text files. A CSV is the same thing. It is the only thing special about it. You don't even necessarily need to have it end in the .csv file extension. Really, this is just a text file. So you have a row at the top that are your column headers, and then you have your data. So this hello table text stuff here table would, that stuff would all be at the top, and then these would be the values. So this is a table representation of what the CSV is. We've got this example CSV. If you're in Excel, you can export any tabular data that way. You can go File, Save As, click Browse, and then down in the bottom right there's a dialog menu to choose what type of file. So instead of XLSX or XLSS, you use CSV, and it will save it as this kind of thing. There's also a VS Code extension if you want to do that for modifying CSVs. You're not probably going to need to do that in this module, but it exists if you want it. So let's go ahead and do our simple case right here. So all we did here is we opened this file, we grabbed the lines, we printed them. So text, cool. We haven't done anything CSV-y yet. So what if we wanted to get individual values? Okay, so we'll read all the lines in our same way. We're going to assume we know the data, how much data is where right now. If you don't know, or really whenever you're using this, you're going to want to use a Julia package, and I'll show that here in a second, but we just assume we know the shape of this data. So we're going to skip that first line. I'm going to close this so you guys can see this a little bit better. So we're going to skip the first row by using this syntax to end. So that gives us everything other than the first one. That's just this fancy indexing that we can do with an array. So then we split each individual input. So what we have in this line, so what one of these row values will be is corresponding to one of these. So we take that string and we split it, and then this returns an array of strings, We can then loop over and put them. First, we need to parse that string into a number. So we parsed it into a float 64. Julia has a method for converting text to numbers. I don't know if we've used that before. I feel like we did. Then you take that numerical value and we can put it in our matrix that we wanted to, and then we can close and print. Close is important. I haven't mentioned this. If you don't close your I/O stream, it will leave the file open and blocked so other programs can't use it. And close also puts the end of file marker on the file. So that's important. Make sure to always close your I/O objects when you're done with them. So we will run this and display our matrix. So now we have it in a Julia matrix. Cool. We have input that we can now, you can do any sort of matrix manipulations and math that you would want to do with that data. So I have a more fancy one that's using this thing. I really don't need it anymore because I actually put it in, yeah, I have one right here. So I've got it in 2 places. Here is one doing the opposite. So we're writing some data. I'll let you read through this. It's pretty much the same as we would do with any other looping stuff. The only thing that's different, so we're making sure that at the end we don't put a comma. So only if it's not, if it's the 3rd index, we don't go into this and we don't, add. So that, and then this syntax is to put 2 strings together. So we have our CSV text. So the thing that we got here, which was the value from here, and then multiply times another thing. It's weird syntax, but it puts a comma at the end. Then we can look at our output here. So it's exactly what you would expect. We don't have commas at the end. Realistically, don't ever write a function like this. Use the csv.jl, but it's illustrative of how to write to text, and it's a good thing to learn as you're going through it. So parse through this and understand this code, but once you understand it, never write code like it again. Sorry for the dog barking in the background. So here we just use tables and CSV, the packages, and we'll write to it with the package, and it will do the same thing. We didn't specify our column headers, so it did it for us. But anyway, this is how you use that. Just for your own knowledge, you're not ever really going to have to use that in this unless you choose to in our project, which we'll talk about here in a second. So then we have JavaScript object notation. So this is a way of storing structured data about objects. I'm going to go shut my dog up. Fast forward if you'd like. Alright, I'm back. Sorry about that. Alright, so we have our struct, similar to what we were using last time. The JavaScript object notation version of this would be something like this. So this defines what it is. If we were to create one of these and put the right values in it, this is what the JSON would look like. So this is a more complex example from our simulation data that we did last time. So you can parse through this, but essentially it's just a string name and then a colon with the value. So when you use the JSON parse method or whatever, it returns what's called a dictionary. You can think of a dictionary as really just kind of a fancy array that instead of looking up things by their number of what index they are, you look them up by value. And by their key is what it's called. So you have a key value. I shouldn't have called this value, but That's hello key. So that's a more descriptive way of talking about this. So you put it in the dictionary, and you can look them up by that. All right. So here is an example, 2 bits of example of, switch this. So we create a bike, we open our IO stream, we use JSON print that prints it to this IO file and prints a string version of JSON of our object, and then we close our IO. And this is the opposite, so we have a simulation example JSON, and then I print out some of the information that I looked up. So I'm grabbing the first bike's X position and printing out all the bikes. So I'll run this. So there's our data, and then I can also go look at the JSON file that I wrote here, example JSON output.json. So there is that. You can format document on these, and it'll format in a slightly nicer, easier, readable way. And then I'll pull up that simulation example JSON. So same thing. Look around, you can kind of get a feel for how these work. One thing to note is, like I said, or with this implicitly said with this formatting when I formatted it, the spacing doesn't particularly matter. But anyway, you guys won't be creating any of those, but it's a very powerful and widely used. So everything that goes over HTTP on a lot of things these days, so over the web, sorry to use programmer jargon, when you make a request to a web page to get some data, oftentimes that data will come back in the form of JSON. So web pages use JSON all the time, and then take that JSON data and display it on the screen using HTML. Anyway, so without further ado, let's get to our main exercise. So this exercise is different than the others. So all of the previous exercises, I've given you a scaffolding of the code, and you were filling in the blanks and using the stuff from the modules and completing it based on the unit test. We've flipped it around. This time, you can build anything you want. So as long as it fulfills these requirements, I'll let you read through them yourselves, but essentially I just want you to get used to the idea of going straight from an idea in your head or something that you've been asked to do and building it up from nothing. So you'll write your own functions, you'll write your own script file that runs things. You could use a Jupyter notebook if you wanted to. Do it however you want, as long as it's using Julia and some of these criteria as they're laid out. So I have a couple of suggestions. Find a textbook problem, create a simple game, spend as much time as you want, be as creative or as trivial as you like. Like I said, I just want you to get experience with this. And then there's prep for the final module. So we are using a slightly different technology called Google Colab for the last thing. It's just another place where you can run these Jupyter files. The binder lab whatever thing that we have been using or locally won't work for it unless you're running a Linux computer, which I imagine most of you aren't. So we'll just all do it on Jupyter or on Google Colab, and there will be a subsequent video on how to set all that up. But I kept it short this time so you guys could spend more of your time coding and thinking through this stuff and less time listening to me. So if you have any questions, feel free to reach out. Other than that, I will see you in the next video where I talk about prepping for the final module and what is expected of you in the final module. So.